So this week's lessons and challenges are really set up to prepare you for the assessment. You're going to have a 3-day challenge where you'll be combining everything you've learned so far in the IAC CICD module. So that's going to be Terraform, Ansible, GitHub Actions. You will use GitHub Actions to create a workflow that, upon an event, will trigger and run a Terraform script. This Terraform file will then provision two EC2 resources, one to act as a control node and one to act as a target node. You'll then run an Ansible playbook to, well, from the control node onto the target node to set up a Python Flask application. How's that sound? Right on. So we've got a lot to cover today. I'm going to try to get through the bulk of it. And the format for this week is basically going to be it's a continuous project. Go through the challenge at your own pace. If you're ahead of the instructors, that's awesome. Like, that's actually what we're hoping for. We encourage you to be ahead. And if you're not, that's okay too. Every instructor for the next few days this week will be covering a different part of the project. So I'm going to be covering unit testing in a GitHub Actions workspace, as well as setting up your project to utilize Terraform and Ansible and GitHub Actions. Tomorrow, Reno will cover expanding on the Terraform configuration. So you'll update the workflow to start running some Terraform commands inside of the workspace. And from there, you'll write some Terraform code to provision those resources. And on Thursday, Preston will go over setting up a database. You can go through it whichever way you'd like, either through like a LAMP stack or AWS RDS, and using Ansible to deploy the Flask app and to connect to the database. With that, let's start with our unit tests. Let me bring over my screen. And we're not going to worry about this part too much. I want to get through this rather quickly because the bulk of what we want to cover this week is going to be the actual CICD pipeline. So I'm going to share, not sharing yet. I am going to share what I have in a repository for the what's it called? For the unit testing. All right, can y'all see this? Cool. All right, so what is this? We've got a workflow called Python app. And inside of this workflow, we are setting a name and we are setting a trigger. On any push to the main branch, we will kick off this workflow. We're going to give it some basic permissions. It's got to be able to read in order for us to run our actions checkout. And from there, we'll be using setup Python to set up Python in the GitHub Actions workspace. So with checkout, everything inside of your repository, your folder structure, your files, etc., all of that will be checked out into the GitHub Actions workspace. So that means this requirements file here will be available inside of the work environment. And then we'll use the setup Python action to set up Python, a version that we specify based on what you're running on your local machine. So when you run through this part, you're going to want to match this version to whatever version your interpreter is pointing to within your VS Code or wherever you're writing your scripts. And then we'll set up a step to install dependencies. It's going to run your very basic python-m pip install to upgrade pip. And then we have this little conditional here where it will install a requirements.txt file if and only if it exists. This will bypass the error of the entire flow failing if that file didn't exist. And from there, we'll be able to run some tests. So let's see what this looks like locally. Okay. If we look at our project, we saw the workflow. Let's take a look at what the application itself looks like. Here we see that we've got a few folders. We've got a project folder. We got our requirements.txt file. We set up Flask, Flask SQL Alchemy, and Flask login. But we're not going to really do anything with any of that today. We're just going to do some very basic setup. And you can worry about fleshing this out on day 3. So if we go into our project directory, we could see we have multiple files, right? We have this underscore, or what is it, dunder init.py. And what this dunder init does is it specifies for Python that we want to treat this directory as a package. So we'll be able to run package commands on this directory. We'll be able to run Flask run on this directory. And this is essentially the file that will act as the application. So if we go into this file right now, we can see that it's got some import statements. It's importing Flask. I've commented these out because we're not really using them just yet, but I've included them anyway. So you have some boilerplate code in the repo, or in the examples on the repo, I should say. And we've got some conditionals here. Let's not worry about these for now because this blueprint portion is a little extraneous. It's not really required. But if you're interested in working through, like, let's say, some relative file issues, that's what it's here for. It's here to demonstrate how to bypass that. What we're really more concerned about is the routes that we're setting here, right? This should look familiar to you. These routes are what you set in order to for when a user goes to the actual application from a browser, these are the paths that they will use to access the different pages. In this instance, we're really just returning some simple strings because all we want to do is be able to run some simple tests. So I have my project set up. I ran a Flask. Let me actually do my Command R export. Yep. Export Flask app project so that I could run Flask app. This export will only exist in my current session. So if I were to run a new terminal, I would have to call this again. So I'm going to run export Flask underscore app equals project. Project is the name of my folder that I'm treating as the package. So with that, I could now run Flask run. And we see that it's now hosting on this local address. If we go to the directory, we see index. If you go to profile, we'll see profile. Okay, cool. Simple enough, easy peasy. Now, what we really want to do is to be able to test this, right? So when we write a unit test, we first run our imports. We're importing from our dunder init file the create app method that we wrote, and then we're importing the unit test library. We call the test case class from the unit test library, and we use that as a subset of the test class. And within this class, we write a few methods. One, to set up the app, to set up the test instance. So here we're saying self.app equals create underscore app test. We're calling this create app method from our init file. And notice how this method takes in a string with a default value of dev, but we'll be passing in test. And this is where we'll be able to see later on how you can bypass relative file issues or relative file path issues using simple conditionals and a technique like this. From there, we specify a client, and it will essentially just be a test client that belongs to this app object. And then we could write a test for it. So in unit test, if you remember, your tests have to start with test underscore. So what we're doing here is we're testing for an index to return the word index. Notice the B preceding index. This is because we want to use, we don't want to compare the string. It's going to fail if we compare the string. We want to compare the string as simple bytes, which will match the data type of the response.data. So that's why we have that B in there. Let's write one more test for our profile. As you can see, it's pretty straightforward. We're matching the path with what we expect to receive from that path. So in this case, profile returns uppercase P, profile. All right, let's get out of this and let's run our test. So Python project tests.py, make sure I saved. And we ran 2 tests. They both succeeded. Cool. So now how do we do this in GitHub Actions? If we go back to our workflow, we'll see that we have that exact same command as the final step of this flow. So if I push to my main branch, let's see, have I made changes? Yes, I made changes because I added a new test. Git add project tests, git commit, and the -a is an optional flag that adds in addition to committing. So if, for example, I didn't actually write git add project tests.py, if you see like anything red in the git status, that will be added automatically. If you see me type the git commit am, it's just force of habit for me. In this case, it's unnecessary. I could just write -m for my message, but it also doesn't hurt to leave it in there. It's essentially running the add command, but adding nothing. So we're going to say add new test, and we are going to push to our main branch. Cool. Let's check this out. Let's watch the action unfold. So we could see that it's been triggered. It's got that yellow spinning icon thing going on, and it's running a bunch of stuff. Right now, it's on the install dependency step. It succeeded, and now it's running our unit tests. So let's expand that. We see that we have the exact same output here that we had in our local directory. And that's all there is to running unit tests in a GitHub Actions workspace environment. Any questions? All right.
Oh, I've got one. Sorry. Chandra introduced SonarQube to us on Saturday, and one of my questions around SonarQube was, where does unit testing fit in with that? And So I'll ask the inverse of that. Where does SonarQube fit into what you just presented to us?
Sure. SonarQube is a platform, right, that offers a lot of additional capabilities. So you're able to lint, you're able to not really validate, but it parses through code and it interprets code and it kind of analyzes that code and then it returns its opinion of the quality of that code, right? We don't need all of that for what's essentially a super basic application right now. So that's why we're using unit test. The advantage of unit test is it's built into Python. It's an included library. We don't have to do any additional setup. Now, if this was the real app and we were scaling it up and we were building features, there will come a point where it doesn't make sense to use unit test anymore. At that point, we might switch over to PyTest, which is more robust. And as we continue to scale, then it might make more sense to jump into using an enterprise level tool like SonarQube. So really, it boils down to your use case and the scale of your application.
That makes sense. Thanks.
Mhm. All right. So that is our unit test. And now we can dive into our CI/CD pipeline. So I haven't decided yet if I want to just kind of run through the existing project that I have or to just write a new repo from scratch so you could see these commands in action. Do you all have a preference?
A new one.
Nice.
I like the idea from scratch. It definitely would help me.
All right, let's do it. Okay, so let me,
If anyone disagrees, speak up now or forever hold your peace.
exactly. All right, we are going to take the bold and daring route. Okay, so before I jump in, I'm just going to share what the README looks like so far. GHA, TF, ANS, I think is the name of it. Okay, so let's run through this just so we're familiar with the process, and then we'll create a new repository and dive in. All right, so we're gonna start a new project. I'm gonna show you all a really cool CLI. It's called, I guess, GH. It's the GitHub CLI. It wasn't created to replace the Git command line. It was created to complement the Git command line. So there's a really cool command, GH repo create, which will essentially initiate an interactive terminal session where it will ask you questions. It's going to prompt you for values, and it creates a remote repository all from your command line. And then it will clone that remote repository onto your local machine. So super easy, super fast. We're going to run through that. We're going to use that to set up our new project. Once we do that, we will set up our basic file structure. We got to use GitHub Actions. So we'll be creating a workflow. And we know we want to use Terraform, so we'll be making a Terraform config. And that's really all we need to start. From there, we can start fleshing out our workflow. We're going to use some actions, just like you saw in the previous example, how we use the setup Python action. There is a setup Terraform action provided by HashiCorp. So we're going to use that to set up Terraform. And once it's set up, we don't need to call it anymore. When we run our subsequent Terraform commands, Terraform's already existing in the environment. We are good to go with running whatever Terraform commands exists. And the one last thing that we're going to do today is I'm going to walk you through, well, I'm going to walk you through all of this, but if you want to keep in pace with where the assignments are, laid out, or where the challenge is laid out, I should say, you'll want to be able to do this step today as well. Notice that these are just very simple list commands. We use this to just confirm that this step is working. This step is writing an SSH private key to a file, and we check that file, or that folder, I should say, to see if that .sh folder exists. And from there, when we're ready to actually create our nodes, we go back to our Terraform file, we work on well, we add security groups first because we have to use security groups. And we have this really cool step here, which will avoid some build failures. And then we could start writing our control node. We write the control node to utilize a remote exec provisioner, which you should remember from last week. And we need this in order to SSH into the EC2 from our GitHub Actions workspace. So one more time, we will be creating an environment in GitHub Actions. From that environment, we SSH into the EC2 instance that we create. And from that EC2 instance, we SSH into another EC2 instance. Because we want to install the Flask application on a target node from a control node that we've provisioned through Terraform. All right, I think that's pretty clear. And if it's not, let me know right now.
Quick question.
Sure.
You said you're creating a Git action environment from which you are accessing the first EC2. Okay, so on Saturday we talked about like Terraform state files being created within GitHub Actions, and that resource in GitHub was a temporary resource that was utilized and then torn down once the action had processed. When you're referencing the GitHub environment here, like, is this going to be a permanent thing, or like how are you referencing it? Is it temporary? And yeah,
it's definitely temporary. And this is where the remote state comes in, right? So you could use AWS DynamoDB to set up a remote backend, and that's where you're actually going to store your state.
Okay. Same as Saturday. Okay, good. The world makes sense.
Right on. Awesome. Glad to hear it. Cool. So let's dive in. Let's see this all in action. I'm going to switch over back to VS Code. I'm going to move this out of the way. I'm going to try to clear up as much of my clutter as I can. Let's just deactivate. Let's get out of here. Let's go up one directory. Let's make a new one. I'm going to call it GHA. No, not PY, because that's Python. I'm going to go back up one more directory. I'm going to go into my GitHub Actions, Terraform, Ansible directory, and I'm going to make a GitHub Actions, Terraform, Ansible's demo directory. Very creative with the names, as you could tell. And all right, now let's check out this really cool GitHub repo create command. If I run GH repo create, it's going to ask me what I would like to do. I would like to create a new GitHub repository from scratch. I'm going to name it the same thing I named my directory, because that's how I roll. And I'm going to hit enter, and it's going to ask me where I want to create this repository, what organization. I'm just going to select my personal one because it's just a demo. And I don't know, this is a demo. This is a description. And then we set the privacy of it, the visibility of it, right? I'm just going to make mine private because I'm just going to delete it later anyway. And yes, I would like to add a README to initialize the repo. And yes, I would like to add a git ignore. Now it's going to ask me to select a template. If we were, well, since we are creating a Python Flask app, even though it's not going to be in this repo, I'm just going to select it anyway. And because it's just a template, you could always add and remove from it. So we're just going to select Python. I don't need a license. And yes, all of that looks good to me. So I'm going to say yes. And then I'm going to say yes to this so that I have it locally. Now I could just CD straight into it. No swapping between the GitHub UI and your CLI to run Git commands. If we do git status, you'll see that you're already set up to link to your remote directory. So here we're linked to the remote repo, and we're good to go. We're ready for writing out our code. So once we do that, we want to create some repository secrets, right? We're going to need our AWS access key and our AWS secret access key. We could also use the GHCLI for that, right? Yes, we could go into GitHub, into our repository, and click around until we're into settings and secrets where you'll normally set your secrets, but we could also do it from our command line. Let me check one thing first, though. I want to see if I have SSH key in the right directory, because we're going to need this as well. So yes, I do. And now let me see if I know where my last environment file is. So no. Oh, it's going to be up 2 directories, right? Okay. So here we could do a GHTF ANS. This looks right so far. I think my environment file is in this directory and it's hidden, as you could see. So let me actually just check everything inside this directory. So I'm going to do an ls-lah. And I could see this is where my environment file is. The reason I'm doing this is because I want to know where it is so I could pass in that relative path correctly to my ghsecret set command. So this command with a -f parameter for file will allow me to create a GitHub secret in my repository using an environment variable, or sorry, an environment file with environment variables straight from my command line. So let's do, what was that path? It was 2 folders up. It's inside this GHA TFANS directory inside .env file there. So let's hit, well, actually, before I hit enter, let's look at our repo and make sure that it's not actually there, right? So if we go over to our new demo, and we go over to our secrets, we can see that we currently have no secrets. All right, so I'm going to run this, and it's created some secrets for whatever was inside of my environment file, right? So now let's go back to our secrets. Let's refresh. Bam, I've got 3 new secrets in here. We could do the same from really any other file. Syntax might be different based on the file type. So for example, if we wanted to create a new secret from an SSH key, let's do a GH secret set SSH private key. And we're going to use our redirect from wherever our SSH key is. So I think it's .ssh and what was called CP class DevOps EW Bravo.pem, I think. Okay. We'll find out in a bit if that works or not. We need this SSH key. Well, like I described earlier, we'll be SSHing from one environment to another, and we'll just use the same SSH key to do that. We need the AWS access key and secret access key to be able to provision AWS resources from Terraform. So that's what all of those guys do. You'll notice token, it's not actually being used. There's actually more than one collection of actions for Terraform. Before I wrote this, I was looking into using some other Terraform actions, some of them requiring a GitHub token. Ultimately went with the one we're using right now, which does not require a token. I just have not removed it from my environment file, but no harm, no foul. From here, we can start creating our files. Well, somebody tell me, what do I want to create first?
Terraform file? I don't know.
That works. We can make a Terraform file. What else will we need?
Oh, .github workflows.
Yep, exactly. So let's make our Terraform file. I'm just going to say, let's save that. It's just going to be an empty file. Oh, I know what, anyone know what I did wrong? I need to use a relative path. So I want to create a Terraform directory. That's where I want to store my Terraform file. So I want that relative to where I currently am. I don't want to create that directory from my root directory, which is what that is. I want it from the present working directory. So we use the dot to symbolize that. And now if we save, we can save. It's not going to complain. And we do an ls. We could see we've got a Terraform directory. And if we ls our directory, we see our Terraform file. And somebody told me that I need to create a GitHub Actions workflow next. The directory is pretty much always going to be GitHub, not GitHub, it's hidden. And then workflows, I believe it's plural. If I'm wrong, then we'll change it. But that's where I'm going to store my workflow. I'm going to call it tf-apply. It is a workflow, so it's a YAML. And let's save. So let's start working on, well, let's throw some boilerplate into the Terraform file, actually. Whoops, not that one. I want to see that one. So let's open up our Terraform file. We definitely know we want to use the AWS provider. And the version I'm using for AWS is, this provider version for Terraform is the one that I've been using locally. So that's what 4.16 is. From here, we can leave this alone and we could go back to our workflow and start creating some code. So let's open up our GitHub workflows tf-apply.yaml. And the first thing we want to do is give it a name, right? So let's just say Terraform apply, because that's what we're going to do with this flow. And we want to then specify the event that's going to trigger it. In my case, this is what I like to do. You don't have to do it this way. I don't want it to trigger from main. I want it to trigger from a staging environment. That way, when I'm ready to, that way I don't clutter the main branch with all these commits, right? Because when you're developing or when you're in staging, you might make a lot of mistakes, or you just enjoy flat out exploring and trying different things. And that's going to require creating a lot of commits because that's a lot of trial and error. So that's why I like to use a specific branch for either dev or staging, right? So that's what that is. We then specify release type. Well, this is not necessary, but what this does is if I were to then push my changes to main, it's not going to trigger this flow, but I could release all of the changes that have been merged to main all at once, and that will trigger the flow. So that's sort of standard practice for version control on an app that multiple people work on. So that is that. Now we could start setting some default values. We are going to want to use the shell environment of bash, and we're going to set a working directory, and I'm just going to set it to Terraform. And I'm going to make sure it's going to be relative to wherever this environment starts out in, using the period, and then I'll add Terraform. Now we can add some, just like we did earlier, permissions. So permissions, we want to be able to read for sure. And we want to be able to write. We need the ability to write. Well, actually, no. I don't think we're using this. We might be using, I can't remember. Well, we'll add it, or we'll add it and we'll comment it out. And if we run into an error, we'll know why. Okay. And let me see. Now we are ready to write out our job, or jobs plural, I should say. I'm just going to call it build. You could call it whatever you want. In this case, I'm just going to call it build. And we're going to say what it runs on, right? It's pretty standard stuff so far. So it's going to run on Ubuntu. And then the first step is to call that checkout action. So we're going to write a step, we're going to write uses, and we are going to use the actions /checkout. I think we're using V4. And that is my first step. If I were to git status, git add.github, git status, or sorry, I don't need to run that again. Git add Terraform, git status to confirm, git commit init commit, git push origin stg. Oh, actually, I don't know. I did not. I forgot to switch branches. Okay, git checkout b stg. So let's check out a new branch. Now let's try pushing to this branch in our remote repository. It should create it. Git push origin stg. All right. Let's open that up. And I really should have had it maybe trigger off of a merge, but we're here right now. We could see that it's already failed. Oh, okay, I see. Anyone catch this? It's got to be plural. So let's save that. Status, git commit am this time. It's going to add this file automatically for me. Fix, pluralize content. Git push origin stg. Right, let's go back to our actions. Another flow has kicked off. Let's look at our logs. And hopefully it doesn't fail. Nice, it completed. Okay, so we are in a very good state so far. We are ready to keep chugging along. Now that we've set up our environment to utilize the files that we have in our repository, we have to continue setting it up by adding Terraform. So what am I doing? I don't need to specify steps again. I'm going to say, I'm going to give this one a name. I'm going to say set up Terraform. And it's going to use the action called, it's provided by HashiCorp. So HashiCorp / setup dash Terraform at v3. And just like with our Terraform file, how I specified a specific version, I want to do that here as well. I want to use a specific Terraform version. If I go to my local machine, my terminal, and I write Terraform, I always forget which one it is, dash version maybe. I'm using 1.8.2. So that's what I'm going to specify here, because whatever I'm writing locally, I want it to run the same way essentially in my new environment, in my GitHub environment. So Terraform version of 1.8.2. All right, so let's save that. Let's also add another step. This one's going to be called, this is where we write that SSH key, right? So write SSH key to file. So let's then call a run, and we're going to use this pipe character to specify that we want to pass in a multi-line command. The first thing we want to do is make a directory. We're going to use -p to, I think it's for ensuring, I think it's -p stands for path, I think. And I think it allows for the nesting of directories. But the other cool benefit to this is if the directory already exists, it won't error out. So it will only create a new directory, nested directories that you passed in if they do not exist. So that's why we're using this. We're going to say .sh. It might be created already. It might not be. I can't remember. I'm going to do this just to be safe, just so I don't have it error out on me. And then I'm going to write echo, and I'm going to pass in the SSH private key. Oh, I remember we forgot one step, so I'm sorry about that. Let's backtrack a bit. Let's slow our roll. This doesn't mean anything right now. And we have to actually set our environment variables first. So let's go up here. Let's add some environment variables. And we're going to essentially add the exact same stuff that we added to GitHub, right? So SSH private key, very loud in all caps. We are going to reference the secrets.sh private key inside of our what is it called? Our repository, and we're going to correct this hashtag, which was supposed to be a $. And that is the private key that we used GH secret set in our command line earlier to create. And we'll do the same thing with the ones that we pulled from the environment variables file. So AWS access EID, $. I think this is like Golang syntax. Secrets.aws access _ key. There's a tool called Retool that utilizes this syntax as well. We also need the secret key, secret access key. We need to spell it correctly. And surprise, surprise, it's going to be pretty much the same thing. Okay. Now we could also set our region. So let's do that so we can have all of this organized in just one region. I'm going to use US East 1 because that's my favorite. And let's go back to where we were. So now that we've got our environment variable set, this actually makes sense. This is actually going to reference something. So what we want to do with this SSH private key is, can anyone guess? Because we want to make a file, so how are we going to do that? with our handy dandy redirect. So let's get our redirect caret in there. Let's toss it into that .ssh folder that we created. I'm going to call it ID_RSA. And then we're going to run our chmod on it. So chmod and a path to this file that we just created. I think I mentioned earlier that we could use some print statements to confirm whether or not this succeeds, right? So if we write a name here, let's run, let's just do an ls-lah from this this tilde directory, forget what it's called. And this will let us know if .ssh was created. And let's also create another step here to repeat this to confirm that it wasn't there before. So that should return an empty directory, or sorry, not empty, but it's not going to have .ssh, and this should show .ssh. And then we could also, well, no, I'm not going to bother with that. We're going to save. Let's go ahead and test it out right now. So git status, git add, or actually git commit am, and I'm going to say, what am I testing here? SSH directory. Git push origin ftg. Command click the link and actions. Oof, got a failure. So I've got a failure in my YAML syntax on line 34. That indentation was completely wrong. So I think that was one tab, right? Maybe it's
Line 39, your indentation for TAC name. 36, yeah, TAC name.
good catch.
Different. Yeah.
Okay, let's save that. So was this like just a bad error message? That might have just been a bad error message. Well, we'll find out, I guess, right? Status, git add, or git commit, am, fix indentation. This is probably going to be one of many. So let's repeat the flow. We're going to push. We're going to click on the right tab. Oof. It's going to complain about 34 again. It is. I'm going to double check my other apply script because, yeah, that should be it. Because I honestly, I hate wrestling with YAML syntax. It's like one of the
it uses with version.
what's that?
It says uses with version, with Terraform version.
Oh, with. That's what I was missing. Okay. I see. Good catch. Okay. Thank you. So with, now my indentation is actually fine. So let's save. Let's decommit. And we are going to push. Now we have another failure. It's a failure on some empty line for some reason. Let me save here.
Do you have to indent line 38 and 41?
Line 38 and 41. I don't
That-
think so. I hate this kind of like syntax, but yeah, it's got to line up with the dash above it, I believe. I don't know why it's telling me line 27. I don't see what's wrong with this. It's an empty line. my width. Okay, let's see. So we've got, that's a separate step. This is name. Oh, I think. Actually, no. Yeah, you were right, Eric. Or actually, who said that? Was it Eric?
Yeah.
Okay, yeah, I think we do have to move these. So let's save.
In the actual lesson, they're not lined up.
I'll have to fix that probably.
Then
Okay.
you would have to move 43 to 45 too.
Okay, 43. Oh, right. Good call. Yeah. Yeah, the thing about the lessons is in Markdown. Yeah, when you're like copy pasting from like YAML into Markdown, sometimes it doesn't, yeah, include all of the indentations or the changes and stuff. So like there's a lot of like manual tweaking that's got to be done afterwards. So I probably missed that.
Yeah, I'm not someone to sit here and go, "You're wrong." That's not what that's about. I just was noticing it, so no, I get it.
All right, so now we could run under git commit. I'm going to use AM so that we don't have to do add. And we're going to say fix indentations number 2. Push origin STG for staging. And nope, that's the wrong one. It didn't fail immediately. Nice. It succeeded. All right, great work, everyone. I was completely blind to all. I just do not like YAML syntax. It's so frustrating to wrestle with, in my opinion. But it is what it is, right? All right, so now we should be able to, because we confirmed that, oh, actually, we got to go back and look at our logs because that's what we're trying to do. We were trying to confirm that this folder was created, right? So we have 2 steps where we're listing the workspace contents. In this first one, we do not see a .ssh folder. In the second one, we do. So we know this succeeded. All right, with that, I don't need these anymore. I'm going to delete them. And I'm going to go ahead and work on my next step, which is to run a Terraform command. And what command do I want to run? Anyone?
Init.
Exactly. We always want to run a Terraform init first and foremost in every new directory. So we're going to use a Terraform init. I think it is just run init. We could also, in addition to giving it a name, we could give it an ID. I don't think this is necessary right now, but I'm going to do it anyway. So that's that. I'm going to, well, we don't need to test this. We'll test this alongside some of the next stuff. So we'll save this and we'll switch over to our Terraform file and we'll actually start adding some stuff to this. Here we could start to actually create our control node, right? Or actually, no, we want to do our security groups first. So resource AWS security group. And we're going to give it a name of, I give it a long name before. I'm just going to call it control now. Something a lot shorter. And let's do name equals yeah, we'll just call it control and give it a description. And one thing I love about Terraform is Terraform format. So you could be totally lazy with your formatting and just let Terraform format fix everything for you. So we're going to do from port equals 22 to port also equals 22. And this is going to be our TCP protocol. I think it needs to be a string. And then our CIDR range for blocks is going to be the 0000 just to make testing a lot easier for everyone. So let's do that. Let's copy paste it and repeat it for a few other ports. And we want to do this for 80 as well. I'm going to use Command D to highlight the next instance of 22. I'm going to paste again. And I think now we want an egress. Command D, hit 0, set this to -1, and save. And now I'm going to open up another directory so I don't have to leave this one. Or yeah, I'm going to split the terminal. I'm going to go into my Terraform directory where the script is at. And I'm going to run Terraform format. And voila, it's now pretty again. Okay, so that's one security group. We can do another one for our target node. And we can just copy paste everything. Command D to replace these very quick. Target. And this is going to mostly be the same, but we're going to want an additional port exposed specifically for the Flask application, which is going to run on the target node, but not the control node. So that's that. Let's save that. And I'll just go ahead and add this right now and explain the reasoning for it. But when I was testing this out, as you could see, like we're already starting to do a lot of commits, right? In order to test our YAML, for example, it might take a few pushes to get it all to work. When you get to the point where you're also provisioning AWS resources, it can be a pain in the ass to try to resolve a failure only for a different failure to happen. And you find out it's because it can't create a security group because a security group already exists. So what we could do to bypass that is we could check first to see if it exists. And if it does exist, we'll run our Terraform import. So check and import existing security groups. And here we're gonna do run, and we're gonna use a pipe command to specify a multi-line command. And we are gonna say existing control security group. This is just a new variable. And we are going to point it to AWS to describe security groups. And we're going to filter by a group name and that value. Now we could write a conditional. So if the existing control security group is empty, then we will run Terraform, import AWS security underscore group. Or I said is empty. I meant to say is not empty. Then we will import the security group. And I'm going to fill in the S that I'm missing. And I'm going to pass in here the name of my security group, which is just control. And this is going to end the variable for existing security group. Okay. And because we're writing this out in Bash, we specified a Bash environment earlier, we have to use FI to end the if statement. Now we'll do this again, but we're going to copy paste because that's a lot of nonsense to type. And we're just going to change control to target. And I'm going to use Command D to hopefully highlight all the right values. And then I'm going to replace that. Oops, not values. Target. I'm going to replace that with target. And I'm going to save. And let's see if that fails. Okay, I'm going to save this as well. Oh, I'm missing a bracket somewhere. I must have forgotten to. Okay, that should be it. Got target, I've got control. They are named correctly. I'm going to save status. The cool thing about -am is that we'll add everything in red. So git commit am, what is this? check for, or I'll just say add security groups because that's actually what we're doing. So when it gets added again, we'll see that our directory is clean and that 2 files were changed. Now I push to my staging branch. And if we go back to our GitHub Actions tab, we are happy that it didn't immediately fail off the bat. And we sit through the run. All right, it's running init successfully. Init has been, or Terraform has been successfully initialized. And then we have some kind of an error here in our check and import existing security groups. I have what looks like maybe an extra comma somewhere. So for input, expected second, received none. For input group name, group underscore name. Describe security groups. Filters, oh, group dash name. Is it complaining about? What is complaining about this space? Let me get rid of this. Oh, actually, this isn't even complete. Right. So I'm missing some additional code here. This is going to be values plural equals. I think it's going to be the name. So in this case, it's going to be control. In this case, it's going to be target. And then we want to actually run a query. So query groups. Group ID. And we'll output some text. And copy paste this into this next line as well. Save. Maybe fix. What step is this called? Check security group step. Which origin TG. Hopefully it will succeed this time. Partial credentials found in environment. We're missing our AWS secret access key. That's interesting. Oh, I'm missing the underscore ID, aren't I? Is that what that is? Let's see. Let's go back to our GitHub Actions. I do think that's it. Let me just go ahead and okay, see if that was it. Oh, it's the wrong tab. Let's see if that was it. And save, right? So our credentials found in AWS secret access key. Okay. Let me,
Is it a keyword for configuration? So it must be AWS secret access key.
Yeah, it might be. And maybe what happened was this as well should be ID. Let me double check my secrets to confirm. So let's go to our settings, our secrets, and right, it is without ID. So let's get rid of that. Save and and third time is a charm. So let's check this out. Nice. All right, I succeeded. So it looks like it successfully created our resource. Let's actually hop into AWS right now. We might have a few different instances running. I am in the wrong region, so let's switch over to East 1. Oh, can anyone tell me why we don't have our instances yet? Because we've only run our commit. We haven't actually run apply yet. So I think that's going to be one of the next steps. But before we do that, let's actually go ahead and create our control group because that's going to be super. Oh, we haven't even written the control node. Whoops. I'm jumping ahead of myself here. So, oh wait, no, we did. So the control node is here. Oh, no, that's the control security group. That must be why I named them what I did before. So now we want to create an AWS resource. Right? So AWS instance, we're going to call this control. And we want to specify a few things, right? So like the AMI, for example, the image we want to use, I'm just going to reference that from the other. Yeah, there it is. Because I'm not going to have that memorized. So that's our image. That should be Amazon Linux 2. We want to use T2 micro. And we want to set our VPC security groups to aws.securitygroup.control. And we actually want the ID, not the whole control group itself. And then we're gonna give it a tag, so it'll have a name. Equals. All right, so let's save. Let's go ahead and run a Terraform apply. So I'm gonna save that. I'm gonna add another step. And Command T, Command T, apply. And let's save. Oh, no, before we save, it'll very likely prompt me, right? It's going to prompt me for approval. So we're also going to pass in auto approve. All right, now we can save. And let's push to our staging branch. All right, it's running our init, successful. It's checking for security groups. It's running apply. We see a lot of green pluses. That's good. I think I might be missing something still, but let's ignore that for now because it didn't fail. And this is where it might start to slow down a bit. I think when I was running this before, my runs, I think at their max were like maybe 3 to 5 minutes. There were times where it would just hang. Like if it was longer than 15 minutes, I would just kill it. Let's see. Okay, it says it's successful. It says 3 resources were added. So that should be our 2 security groups and our 1 EC2. So let's refresh. We have our control node. And what is associated with this control node? Let's look at our security. We are using 2 security group rules. Don't have names, but they belong to this control group. So everything is looking good. All right, any questions so far? Okay. I think the last thing I'm going to show is a block for using a Terraform provisioner. Unless you all just feel like you're ready to jump in, because Reno should cover provisioners tomorrow again as well. So how do y'all feel? Do you want to keep going or do you want to dive into the challenge?
I'd like to keep going, but it depends on what the rest of the room feels like.
I think we're gonna run into an issue where, just like this Saturday with Chandra, you pointed out that since this runs based off of GitHub Actions, the state, Terraform state isn't on a local. And so if we run this again, it's going to not know where to reference our resources.
Let me ask you though, you'll be running it from your local machines on a repository that you've created, right? Not a fork of anything.
Yes. So, but because we're running the Terraform apply, only based off of GitHub Actions and not locally, so it's not going to make a copy on a repository, right?
No, that state file will only exist temporarily inside of this GitHub Actions environment, and then it's going to like disappear into the ether once it spins down.
Yeah, that's what happened for us.
Why was that an issue?
What was it? I think it's because when we tried to make a change to the resource, it doesn't know where to reference the resource that was just made because the state is not there. It has no state to reference the resources that were just created.
Why aren't I experiencing that?
I think it's just because you just created it. But if we need to make a change now, I think we might have an issue.
But you wouldn't be pointing to the same like security groups or anything though, right? Like you'd be making new ones. You'd be naming them whatever. Like you could name yours like yams-control.
I think when Chandra was going through it, he did an example where the security group name was already attached, and even if we, I think, well, I guess deleting it probably would have been fine, but he was trying to avoid us just deleting or renaming to like a unique name. But the one thing that was also different, I don't think we had a conditional. Like, doesn't your workflow conditionally check?
Yes.
I think this was just directly applying.
Yeah. So let's see right
That's
now.
what I recall.
We could see that we've got. We'll look at our security groups. We'll see that they exist, and we'll run this again, and you'll see what happens during that step. What did I call it? Just control and yeah, there's control. Really should have named it something. Yeah, let's run this again. Let's do what can we do? We could go ahead and copy paste this into a new instance. This will be the target instance. So now we have a change that we could push. Security groups are still up. And oops, I did not add the A. Git push origin staging. Or if we go to our target node, when we get to the step where it checks for existing security groups, it did an error out. I'm kind of thrown off by what this is referring to, but if we go to my previous repository, there should have been some runs where it failed at that step. I'm not exactly sure what numbers though. I wonder if it's search it. Okay. I'm looking for a failure due to the security group from yesterday. It's weird. Where I added the check for the security group, there wasn't an immediate failure before it. Let's look at it anyway. What happened during this run? Oh, I canceled it. That's why. So what happened here? I guess that's what we should be seeing, the green text saying that it's successfully imported. So my code might have a typo somewhere. So let's double check. Well, let's also check on, yeah, it failed. It failed on, right? It failed on the apply because the security group already exists. So what is wrong with the check? We go to this check here and we compare it to, I think it's this one. Right, this one's from yesterday, TFNS. And the one above is from today. So if it does not equal none, then now let's look at the config from yesterday. Oops, I'm gonna copy paste this because I think my naming convention probably is getting me confused somewhere. Okay, right, this is the name of a security group, which is what we're doing up here. Values equals control. Looks right to me so far. I'm not seeing anything obvious.
Julius, can you talk through that logic there?
I could try.
Yeah, just on your check there, existing control SG, is that referring to, are we checking the Terraform file or are we checking, like what are these variables associated with?
Here, not yet. Here we're creating a variable. So this is like a fresh new variable that we're creating. And I'm just naming it as existing control for the security group. And I'm equating it to an expression that's going to be evaluated in bash and shell using this $sign, right? And this expression is essentially a command that's being run inside of the shell environment. It's the AWS EC2 command, describe security groups. So it's going to grab the security groups using the AWS command line, and it's going to filter by a group name where the values equal this value. So it's going to look specifically for Terraform security group with this name, which we have inside of our Terraform file. It's then going to run a query on this, on the group IDs belonging to this group, which is why we're just using an index of 0. And it's going to output that to some text. And if what we've stored in this variable is not equal none, if it's not empty, then we will run a Terraform import where we import a security group resource with this name. And then we pass in that name or that value from the variable again. Does that make sense?
I think so.
It's not exactly seeing where my syntax is wrong. And if we go back to the exact error message, well, it actually didn't give us a very exact error message, did it? It just kind of ran through this and nothing failed, but it's showing us that we are missing, it's telling us that we're missing what, a bracket or a tilde, or not a bracket, a tilde, whatever this backwards mark is called. It's kind of confusing because this left bracket looks like it would match with this right bracket. So is it telling us that we're missing a bracket, or what the hell are we missing? Yeah, if we compare this to, not that one, from yesterday, or is this yesterday or is this today? Oh, actually, that's a red herring. Looks like, actually, no, I'm getting mixed up with my repos. That's the same one from today. Which one's from yesterday? Okay, this one's from yesterday. So if we go to actions on this one, and let's go back to where we added that check. In this step, oh, it just collapsed it. Whoops. In this step, it's not showing us that. So
Are you able to do a search string on it or like step through the lines?
let's see. Yeah, let's compare. Okay, so first things first, we have our existing control variable set, an existing target, existing control, existing target. Yesterday, we set AWS EC2 describe security groups with filters with name equals group name. let's Command F. That looks like it's the same. From there, we have values equals control, values equals target. And yesterday we were using this name. Today we're using this, so this should be correct. We then say query to, okay, and that matches. If the existing control group does not equal none. Oh, what's that? Oh, but it's just a space. I'm just missing a space here, I think. Yeah, if I add that space and then we rerun the search, it matches. Then we have Terraform import AWS security group. That should match. Looks like it matches. Have the name control, and then the variable that we created. Still looks good to me. Now, are my indents and everything fine? It really couldn't have been finicky about that space, right? I really don't think it would be that, but just to rule it out, we can go ahead and push this. Whoops. Oh, no. Forgot my commit. Got my commit commands, and I'll get push for staging. Import prepared. Wow, it was really complaining about that space. This is why no one likes shell scripting. All right, so this is what should happen if the security group already exists and you have this conditional. It should pass. It should no longer fail. So do you think that's gonna solve your issue, Yams, or whatever you guys were experiencing on Saturday?
I think Saturday's issue was a completely different issue where we needed to still keep track of those resources. So if we wanted to make changes to the resources themselves, like simply changing the name of them, but not creating a new instance of it, then we needed to keep track of remote state
Do you remember how to do that?
ish. He put what looked like almost a one-liner into the Terraform. No, into the GitHub actions, the YAML right here, to set up. I think he put it into an S3 bucket for remote state.
Yeah,
is
it should
that-
be the Dynamo
Dynamo.
S3 configuration. But I think he was just pointing out that without that, we like couldn't run actions and keep track of state in Terraform. So like like I guess we would have to write checks for each thing to get it to keep working, like how you have it working.
Would it solve it if you set up a remote backend and stored state in there?
Well, I don't think there was anything to solve per se. I think he was just showing us that that's like an advantage of this state. Is like one problem is that without the state, then it will assume that the security group that's already in use is there when it runs. But then if you update the state and have in a remote backend, then it can pull down the state and say, oh, that's not being used. used, and then you don't have to write the check at all even.
Got it. Exactly. Okay. So for this challenge, at least this part of the challenge, it's going to be tedious, but because you're not storing state, you're going to have to deal with, we've already gotten past the security group thing by using the import, but for EC2s, you'll probably just have to manually delete them individually, because that's why they keep creating them, because we're not storing state. If I were to set up a remote backend and store state in there, then I wouldn't have to continuously do this. It would update the instance when I rerun the Terraform file.
And then we could just like change the names of things or whatever, right? I think that was what Chandra was trying to show us, was like, rather than having to create a new instance or delete, that having the state lets us do that.
Right, exactly. When we did the remote state exercise like several weeks back, I think everybody was sharing something, right? Like I think I ran the remote backend, but nobody else had to do that, right? Once I set that up, then everyone was able to store their state remotely. Do y'all remember?
I'll be honest, that was one of the, I guess, shakier lessons for me. And what's strange is that the lessons continue after that. They didn't touch back on that issue until just this past Saturday, where all of a sudden we needed a backend, a remote backend, or a remote state. So that's why it was sort of, oh, okay, I sort of remember that lesson.
Let me double check something. All right, so we could do something similar where I'll set up a remote backend and you could add that backend. But it wouldn't be for an S3, right? Because we're not using an S3 right now. Or no, we specify the S3 because that's where we store the state. My bad. So where you have your Terraform required providers, will add something like this. And as long as this bucket exists and the DynamoDB state lock, you'll be able to store your state in this bucket. But I would have to, somebody would have to set up. It doesn't have to be me. It could be me, but you can also do it individually. So like you each use a different bucket if you want to try and run through that on your own. Or you could share a bucket. Let me see if there's anything else to it, because I thought it was pretty yeah, it's not one of my favorite lessons, and I didn't write it. It's one of the old ones. So remember correctly, when I created the back end, this is all that was. We were setting a bucket, which we called TF_S3_state. We were specifying the versioning we were using. We were also setting some encryption rules. And we were specifying what table we would use in DynamoDB, and we were calling it state lock. So this sets up a bucket that you could remotely store state in. If you reference this exact bucket, then you're good to go. Otherwise, you would have to set it up yourself. Does that make sense? Yeah, so I could spin it up and I'll just like let you all know in Slack what the name of the resource is. or you could try to set it up on your own if you feel like, if you run into the need for it. So that's that. Where are we at right now? We're at 7:10. Let's see. I don't want to use up everyone's work time, so let's do this. If you want to stay and we'll continue with the lecture, by all means stay. I'll run through it. But if you feel like you're ready to go and you want to jump into the challenge, I'll open up breakout rooms as well. How does that sound? Cool. All right, so I'm gonna open up some breakout rooms and then we will run through. What are we doing? We roll the control. Oh, right. We were going to use provisioners to SSH into the EC2 using remote exec. So that's what I'm going to demo.
So Julius, how much longer will that take? And do you think like a 10-minute break might not be a bad idea?
Okay, yeah, that's a good point too. Like we have been here for a while. So yeah, let's do that.
I just have a bird I need to take care of, so that's what I'm in.
I'm going to cut the recording and we'll be back. Or actually, how about this? No, I was going to suggest continuing at 9, but that doesn't make any sense. You wouldn't. Well, actually, where we're at right now, you should have plenty to work on to get started, right? You're not going to be getting to the portion that I'm going to be demoing next for a while anyway. So what if I just resume at 9? How's that sound?
That works for me.
Okay.
But what does everyone else feel?
That works for me. I do have a special request, Julius, for not the lesson, but for at some point. You were using staging and you talked a bit about your GitHub actions associated with some enterprise practices, like working with multiple developers. And at some point, I'd love a breakdown, like Barney style, maybe a whiteboard and drawing out or something, how you use branch staging, a staging branch in your remote GitHub with fellow developers, and just kind of walk through just conceptually where, how it all is going and how it fits into production.
Sure. Let's do that. Let's sync up after a break, and I'll walk you through that in one of the breakout rooms. How does that sound?
Oh, that'd be great. Yeah, thank you.
Cool. All right, breakout room should be open, and we will resume the lecture at 9 during stand down. And of course, Edwin and I are here in the main room to answer any other questions as they come up.
Thank you.